Okay, like many of you, I upgraded from the Osmo 2 here, the Pocket 2, to the Osmo Pocket 3. The larger sensor and the bigger viewing screen are all a big worthy upgrade there. But before I had the Osmo 2 here, I never did have an Osmo 1, but I did have what they call the Osmo Plus, and you can see just a big difference in the size there. And you'd think that this could hold like a full frame sensor or something, but it actually had a smaller sensor than what this Osmo Pocket 2 has. It did have an advantage of, it's got a cooling fan in the back there. And I think it had a 3.5 optical zoom, and I think it also had maybe an adjustable aperture. I know the aperture would change when you zoom in. It would go to I forget what the numbers are. It went from like 3.5 to 5.6 or something like that when you zoomed all the way in. It was always just kind of heavy and awkward. I mean, you obviously couldn't fit it in your pocket like you could with a Pocket 2. And it only had 4K 30. It never had 4K 60 like the 2 had. But I did have a kind of a cool accessory for it. It was they call it the Z-Axis here. Let's see if I can mount it up real quick. How does that go? It's been so long since I've used this. It's always been kind of awkward to set up too, and that's kind of why another advantage of this is the Osmo Plus always had to have a cell phone or a smartphone to view for a viewing screen. It never had its own viewing screen. So. And this goes, let's see, I believe it goes like that. There we go. Okay, so, and you can see it kind of gives you a fourth axis there. So it kind of absorbs some of the up and down motions, although when it would go to the extreme end up and down, you'd still see quite a huge bump in the final video. This would go down and secure in there somehow. You could have another mounting location or whatever off of those, but yeah, it's kind of interesting. I always liked the stabilization that this guy gave, although I think this is pretty much every bit as good, although it doesn't have the Z-Axis. I have seen some Z-Axis accessories. None of them got very good reviews. This, for some reason, always got a good review for its time. Even when I had the Osmo 2, the Pocket 2 here, I've always wanted to see if I could find a way to mount that to this, rather than just duct tape or something. I never really did come up with anything. So what I was thinking is that maybe I could mount it, because it's got this protective cap. You can see there's some electronics going on in there that communicated with everything on the handle. And so that locks in there like that. And there's some, it's not totally tight, but it'd probably be good enough to mount something off, maybe like the side. It's got a tension adjustment on here. And what I've seen is that 5, 6 is about midpoint. It has about 12 full turns, but you can see, that's why I'm using bubble wrap here, because I dump it. It's about, I could probably loosen it up a little bit. Yeah, somewhere a little tighter. You see, it's about, yep, there it goes. It's about at the mid-range of the travel on this guy. So So I'm thinking that with whatever mounting stuff I need to hook this up, I'm thinking something like have it hang off the side like that so it's not sticking so far up. But I mean, by the time I get some mounting brackets on here and see, I've even got the extended battery on there, and it's still, you know, still lighter than, you can see that this is actually heavier than this, the way it's sagging like that. So I got some to work with here as far as not overloading this. Even if it does overload, I could probably put the smaller, the non-battery handle on there and pull some weight off of it like that. But I think I could probably make something that still wouldn't overload the Z-Axis. This is the mounting, the protective cap goes in there, and it's got some little lugs in here around the side that it helps lock it into, and then it's got these indexing pins that go in and some holes in there, and then you lock it down, and like I showed before, it holds it pretty good. But I'm thinking that maybe if I reinforce the inside like a piece of aluminum and then have a hole going through it, that might allow a bracket to come down off the side and then hook into the tripod mount along the side, come down here and then angle over and hook in the tripod mount. That might be probably the easiest way to do it. I don't really like the idea of having a little side load on there, but I don't think it's going to be that big of a deal. It's still better than probably mounting it up like that. I got some 1.5 inch 70-75 aluminum. That's like some of the strongest aluminum you can get. 70-75 T651. That's 1.5 inch, but the inside of this is closer to 1.25 inch, but it's like 1.260. And I do have some 1.25 inch 70-75 round, but I would like it to fit a little bit tighter on the inside here. So I'm going to go with the 1.5 inch and turn it down and probably hollow it out to save some weight. Yeah, throughout this whole thing I'm going to try to save as much weight as I can. So yeah, I'll start with that first to make that insert in there. So the plastic cap is tapered. It's got about a 1 degree taper. Up against the inside here, it's like real close to 1.25, like 1.253 or something like that. And then the outside section of it is about 1.270, so that equates to about a 1 degree taper. And but I'm going to rough it out to 1.275 first, and of course face that stuff off. So 1.378. just putting a little place to stop the taper. I'm not going to part it off all the way, just put a groove in it. .550 length is what we're going to come out with. I'll cut this like 560 though. Leave some face off the other side. Okay, so I got the compound set to 1 degree, and I'll feed it in with that. Just a touch off here, up there. Can't get up to the very edge, at least with these. Looks like 1.258, so it could be 1.2, yeah. Maybe something less than that down there. It says 1.255 there, so that might work. Let's see, what is this out here? Yeah, that says the 1.270. So I think I'll add a little bit more taper to it. Okay, so that's where it was before. A little bit more in here. Now I'll lock it down there. That says 1.252. So I think I'm just going to take a extra cut across there. Next, I will be cutting into the face, sort of a tree panning operation, I guess you can call it. I will be going to a depth of about 3/8 of an inch, which should leave a little less than 3/16 minimal wall thickness on top once the part is parted off. Now there really is no critical dimensions that need to be followed here. I'm simply just wanting to shave off as much weight as possible. However, I do want to maintain some reasonable amount of strength along that outer belt so that it still provides some structural integrity to the plastic cap it goes into. That is one of the main purposes of this aluminum insert anyhow. I will be leaving a 9/16 diameter boss or island in the middle. Later on, I will cut a 1/2 inch hex into that island so that I can grab it with a socket while I tighten a clamping screw on top. Now it could be that I may never actually need to use that hex. The plastic cap has 2 protruding tangs on it that will go through this aluminum insert. Simply holding the outside of the plastic cap by hand as I tighten the clamping screw will probably work just fine. The island will also add strength to the top surface and add significantly longer thread length for the clamping screw. I will trim off about 1/8 of an inch from the height of the island, but a good 3/8 to 7/16 available thread will still remain. The trimming is necessary to make sure the island has plenty of clearance from electrical contacts inside that section of the Z-axis. The tool I am using here is an 1.25" boring bar placed into the bar holder at the opposite side. The boring bar is holding a 1/4 inch square high-speed steel bit with a hand ground 1/8 radius on the business end. It also has some additional clearance ground into the outer side of the bit, a necessity for tree panning operations. The way these chips are curling out sort of reminds me of those black snake fireworks. They would start out as a cylindrical pellet about 3/8 to 1/2 inch in diameter and length. Once lit, a connecting flow of ash would form and slowly grow a couple of feet in length until the pellet all burned up. Sort of mesmerizing to watch as it appeared to actually be extruding from the ground. I'll be stopping several times here to clean and inspect, so I'm just going to go ahead and speed things up here a little bit. Next step is to drill and tap for a 1/4 inch 28 thread. tap. I don't know about you, but I've always had a hard time determining how well a tap is going to perform until you actually send it in the hole. You can inspect the cutting edge, beforehand and see that there's no broken teeth or rolled over cutting tips, and feels sharp. It might not feel, as sharp as a new one, but it doesn't feel dull. And you just send it in the hole, and you get about 2 or 3 turns on it, and it just wants to start binding up. And then on the other hand, you can take an 80-year-old barn find like this one with full of rust pits and maybe a few chipped teeth here and there, and twisting it in the hole, and it goes right through, no problem. Might not feel like a brand new tap, but it gets the job done. I actually used this one. It's a 7/8 14. I used it about a week ago and worked fine. I mean, with a drill, you can at least see if they're dull, and even feel if they're dull. You can see that that the cutting edge is not sharp. But even if it's a little dull, it still drills a hole. Might have to send a little more pressure down on it, but it'll make it through usually. It seems like when taps, they lose their edge, and they kind of transform into more of a forming tap rather than a cutting tap, and the torque required to send them in just kind of really goes way overboard there, and I mean before you know it, you're on the borderline of breaking. Best thing you can do is just back it out and run a new tap in there, and put your old tap in with a box of your other used taps, and try it again some other day. So this is the parting tool I'm using in this operation. It's a 1/8 by 3/4 carbide tip. The carbide section is probably still more than half of what it was originally, but there has been some damage over here on the left side. The edge is kind of chipped off, probably about halfway down there. And on the right side, it's got some, you might be able to see on camera there, I don't know, but it's got some rubbing wear on there, so it's kind of limited in what it can still do as far as depth of cut, and not worrying about it galling and jamming in there while it's in the groove. But one day I did decide to try and see if the rest of the blade works, so I sharpened the end up. I knew it was hard material, but I kind of figured it just a regular, like high carbon steel or something like that, nothing high speed steel. But so yeah, I sharpened up the edge, and I tried it in some aluminum, and it worked real good. And I also tried it in some tougher material. It was a grade 8 all thread. It's 1.5" 12 all thread, and yeah, it parted it off, no problem. I think I probably would have had to sharpen it again to do a second one, because there was some definite wear on the tip there, whereas this one's cobalt, I believe. Yeah, same size, but it's not carbide tip. They probably would have done 2 or 3 of those grade 8 all thread before I had to sharpen it. But yeah, you can see there is a little bit of a color difference here, so I don't really know if it's just regular high-speed steel. I think it's something probably tougher, or something that can take more heat than regular carbon steel would. But I'd say it's probably definitely not as good as cobalt, so it's probably just a regular high-speed steel, maybe even a lower grade high-speed steel or something. But yeah, so it's, even if the carbide tip is dead, there's still some life in the back end of it there for lighter duty jobs. It is narrower here. The carbide part, originally it was right at 1/8, 0.125, but this is about 10 thousandths narrower here on the top edge, and like it's like measures like 1/15 or something. So you gotta be aware of that if you're, you know, dimensioning something, a groove that needs to be a certain width and whatever. But yeah, so yeah, it's just not, once the carbide's gone, it's still not a throwaway item. There's still some life to it. And this Cobalt one has got some crazy positive rake there because I was using it to cut into some urethane material for another project I was doing, but it's pretty sharp, or it was, but that worked pretty good. So yeah. We are in the 3-axis CNC mill now to cut the 1/2-inch hex in the center island. And what I got going here is I found a piece of 3/4 inch wide remnant aluminum laying around, and I got that clamped in the vise. I then took a fly cutter to the top of that to square it up and drilled a 1/4 inch hole through the middle of it. I then sent a 1/4 inch 28 bolt through that hole from the bottom and screwed it into the insert. And that's what's clamping them together right now. And also put a piece of paper towel between the two. That kind of seems to help add a little bit of grippy friction between two metal parts that are clamped in this kind of fashion. And since our collet is hiding all of the cutting action, I'm going to go ahead and speed up through this process a little bit. And what the collet holder is hiding is a 3/16 diameter 4-flute carbide end mill. And we're cutting to a depth of about 3/16. Okay, so the 6 points kind of tight, kind of goes on but stops. The 12-point socket slips right on, no problem. So I'll probably leave it. Okay, cutting the slots out for these two spikes here. I'm using a 1/8 end mill, and I'm going 1/8 of an inch at a time, and the diameter of the spikes at the bottom are closer, they're about 0.140 or something like that. So I'm going to take 10 thousandths off each side as I go through, so it'd probably make it about 0.145 theoretically. The depth eventually has got to go all the way through. I'm just doing this operation manually using the DRO, with X0, Y0 being at the center of the part. And I'm just running Y in until it reads 0.425. And of course on the opposite end it'll be negative 0.425. And as I mentioned earlier, X is going to be plus or minus 10 thousandths, and that'll give us the 0.145 dimension we need using that 1/8 diameter end mill. back at the lathe again to drill a 1/4 inch hole through the DJI plastic cap. And I'm using a 1/4 inch end mill for this operation. I think it'll probably cut a little bit cleaner than what a twist drill would in plastic like that. And the insert is installed. It'll allow me to hold the cap securely without crushing it into oblivion. And yeah, I failed to measure the wall thickness on the cap. So I'm just kind of being cautious here, just listening for any breakthrough sounds and looking for any aluminum chips mixed in with the plastic. So that about wraps it up for part 1 of adapting the Osmo Plus Z-Axis to the Osmo Pocket 3. In part 2, I'll be making some sort of a bracket. It might just be a simple Z-shaped flat bar that's bent type of design, or I might have to make it a 2-piece, a little bit more complex design that'll allow the Osmo Pocket to tilt in its mount if I feel that is necessary, but I'll have to think about that. Either way, that should be a shorter video than what this one was, although I'll probably add some weighing of the parts we make and total those up and see how that compares to the Osmo Plus head, and make sure we're still within a balanceable weight limit there. We might have to shave some weight off, but might even have to add some weight, I don't know. So yeah, I should have that up in about a week or so. And part 3 will be, hopefully I'll be able to do a side-by-side comparison of Osmo Pocket 2 and 3 with one on a Z-axis and one not on a Z-axis to see what to see if it's really helping or not. So yeah, so stay tuned for that, and thanks for watching.